Now let's have a look at quadratic functions, because our knowledge of these will be very useful later. So a general quadratic we will write in the form of a half x transposed ax plus b transposed x plus c, and by a form of completing the square we write such a quadratic in this form as a half of x minus p transposed times a times x minus p plus a constant d, where we will deduce very shortly that p is minus a inverse times b, for a and b up there, and d is equal to the constant c minus a half of p transposed ap. The reason this completing the square form is useful is because we can tell immediately from it where the minimiser of the quadratic is. And where that comes from this first term here, this term is 0 when x is equal to p, and hence that must be the minimiser, provided a is positive definite, of course. Alright, so now let's show this by completing the square. And we'll start here to derive something that's in that form. Alright, so we just expand this product. So q of x is a half of what? Well, this is a binomial times a times a binomial. So when you multiply binomials, you get 4 different terms. So let's look at them. Firstly, there's x transposed ax. Then there's minus p transposed ax. Then there's x transposed a times minus p. And then lastly, there's minus p transposed a minus p. And the 2 minuses become a plus. So we get p transposed ap. And then lastly, there's plus the constant d. Now let's group like terms. This first term is a half x transposed ax. These 2 terms are the only terms linear in x. There is a problem, we've got x here and x transposed there, whereas we'd like to factor out the x. But remember that this is just a scalar, so it is equal to its transpose. So we can transpose it and say that it's equal to that. So what's its transposed? The answer is p transposed a transposed x, the product of the things in the reverse order. But a is symmetric, so a transposed is the same thing as a. So we scrub out that transpose. And now you see these are the same 2 terms. So there's minus 2 of those times a half means there's minus 1. So minus p transposed ax, those 2 terms. And then there's these 2, plus a half p transposed ap plus d. And now this is in the form of the general quadratic. This matches the first identically. These are the only x terms that has to match that. So that says we must have minus p transposed a has to be the same as d transposed. And then this is the constant term. And so the constant c must be the same thing as a half p transposed a p plus d. Let's just rearrange these a little. Take the transpose of both sides here and multiply by the minus. We get a transposed b is equal to minus p b. Remember, a is symmetric, so a transposed is the same thing as a. So let's remove the transpose. and hence P is minus A inverse B, as claimed up here. And then over here, it's simply a matter of saying B is equal to C minus this. Half P transpose AP, given that we've just computed P, and that's the second identity there. So that's established the completing the square.